right, so now I'm going to introduce our guest speaker, distinguished speaker of the evening, Deborah Raji. Deb graduated from the University of Toronto with a degree in robotics engineering. She's previously has interned at Clarify. She's currently a fellow in the Partnership on AI. Actually, I should have also mentioned she worked with Joy Balamwini on gender shades, evaluating Amazon's racial and gender bias. And she will be starting a fellowship at the AI Now Institute in New York City in a few weeks. I've heard Deb keynote twice in the last year, and they were both fantastic talks. So I'm really excited to hear what she has to say tonight.
Thank you. Hi. So yeah, Rachel pretty much just gave my whole LinkedIn profile summary. But yeah, I'm Deb Raji, and yeah, at the bottom are sort of just a bunch of the affiliations of some of the work I'm going to present. So I'm currently a fellow at the Partnership on AI. I've worked with Joy Balamwini at the MIT Media Lab, and she started an initiative called the Algorithmic Justice League, and I'll speak to that later. And then I'm also going to mention some work. So I was actually a research mentee at Google AI for a bit, and I'm going to talk about that as well. And University of Toronto, where I'm from. I don't know if there's any Canadians in the room. Probably not. Hey, there's like one guy in the back. Hey, I see you. So I'm gonna just start with this quote, where it's one of my favorite quotes from Richard Feynman, and it says, "Never give a talk unless you know what you're gonna say." So I'm just gonna start off letting you know exactly what I want to tell you tonight. So it's a little bit weird to start with the conclusion, but I just want to make sure that everyone understands sort of where I'm going as I start. So one point that I want to get across is that there's an urgency to sort of this AI ethics and accountability work, because there's actual people actually being affected by this right now. And I don't think this is something everybody understands. AI is sort of presented as this futuristic technology that affects people like 50 years down the road. But really it's affecting and impacting our lives right now, and it's hurting people right now. And as a result, sort of interventions and audits that we develop for AI ethics and against sort of the harms of AI are things that we need to start thinking about right now. And they need to be designed to have an impact. So this is sort of an overview of my talk. I'm going to go over the problem, which I'm sure a lot of you have sort of heard snippets about in the news. I'm going to go over gender shades, which is what I call an actionable audit, where effectively we evaluated, deployed AI systems, and we were able to design that audit in a way that actually got the companies to minimize the harm that they were executing, I guess, upon vulnerable populations. And then I'm going to talk about lessons that we learned from gender shades, things that we wanted to happen that did happen, things that we wanted to happen that didn't happen. And then I'm going to end off with some side effects, consequences we didn't really think about. So the first question is sort of, what's the issue? This is, my background is in robotics engineering. So this is sort of a good analogy in my mind for what AI is versus what we think it is. So to the left, I think, or your right, is Sophia the robot. I'm not sure if anyone's seen her, but she's sort of this like humanoid, futuristic kind of like robot thing, but it's pretty much a puppet, right? So when you actually look at the software behind it, it's not super innovative or interesting. There's only one Sophia, so she doesn't necessarily impact anything. And then on the other side, you have a Roomba. So a Roomba is probably like the most widely used robot in the world right now. And you don't even have to own one to know the name and to have interacted perhaps with one or been in the same room as one. And these are very simple systems. They're nothing like what Sophia is, advertised to be. They're very simple, they're very to the point, they're very reactive systems, and they're not necessarily what we're imagining a robot to be. So I feel like AI is the same way. Sometimes the story about AI is so glamorous and so interesting, but when you look at the way it's really deployed in the real world, it looks more like a Roomba. So this is another sort of interesting slide I wanted to bring up, and it's something that I always mention in every one of my talks because I think it's so important. Kiri Wagstaff is a JPL researcher, so she's an actual scientist, and she had a sabbatical, and she decided to spend her sabbatical learning about machine learning, and this was like 2012, so it's a really good time to get into machine learning. And she got so frustrated over that year that she wrote this paper called Machine Learning That Matters. And in that paper, she pretty much just drags the whole community. It's great. And she goes into the fact that the machine learning community is so obsessed with the algorithm. So we're so obsessed with optimizing, that learning algorithm or optimization for our the particular way that we learn things, that we're missing the point of how to make it useful. So there's a whole bunch of things that, like, in order to, because she was looking to bring machine learning into her scientific work, and she was getting frustrated because there was a lot of questions about data that were not being asked or answered. There were a lot of questions about how to communicate predictions and get buy-in in a particular community that weren't being communicated. So she identified the fact that really when you try to deploy a machine learning model in the real world, it becomes part of a system, and it's not really just about the model or just about the algorithm. It's about so much more than that surrounding it. So yeah, like that's what it looks like in the real world. It looks really messy. It involves a lot of considerations beyond just the algorithm itself. And when you sort of deploy these systems, you end up with sort of widespread bias and abuse. Sorry, I keep like turning my head because it's hard to see the screen. So I'll just look at my computer a bit. But effectively, like these are some recent, not so recent now, but maybe a couple months back headlines. And these are things that really happened. So you had, machine learning systems making sort of discriminatory judgment calls about sending Black criminals, sort of like, I guess, like mispredicting that Black criminals would not, that would reoffend. You had Amazon sort of having to scrape an AI recruiting tool that was biased against women. You have voice assistants sort of not understanding accents. And, one of the more terrifying cases is a medical sort of model that was not performing well on darker skinned patients and misdiagnosing darker skinned patients. And I think like one of the interesting things about machine learning is that it when it becomes an algorithm or when it becomes an AI system, it can do things that are actually illegal and just get away with it. So here's like two cases that I find sort of interesting because they're actually illegal, and algorithms have done this, and obviously like the algorithm is not in jail. So one of them is Amazon's case with the recruiting algorithm. That's discrimination. That's actually, an offense. You're not allowed to do that. And even after they actually deployed this system in 2014, and that was 5 years ago. 5 years of discriminating against women for software engineering jobs because of a faulty algorithm. That's actual, that's job discrimination, employment discrimination. But obviously they don't know who to blame, and as a result, it's sort of just like slipped by. And then the other case is a little bit more interesting. So I'm not sure if anyone here is familiar with Princeton Review, but it's kind of like a study, I guess like a tutoring service, and they had set up a pricing algorithm depending on different neighborhood zones. And that algorithm was actually biased against Asian Americans. And that was discovered, so it was biased against Asian Americans, and obviously that is price steering, which is illegal in the US. So just, algorithms doing things that would not be okay for even a human to do and getting away with it. So what I'm going to talk about today is a very particular type of technology, facial recognition. I'm sure you've seen it in the news. It's very, very popular these days. And the interesting thing about facial recognition is that it's everywhere, like actually everywhere. In airports, in convenience stores, in schools in New York. There were a bunch of New York tenants that found that their landlord was using it. Uber uses facial recognition to verify their Uber drivers. So it's really just making its way into like every corner of life. And people are getting hurt, and we know they're getting hurt because they're suing, which is great. So, we find that these algorithms that are being deployed super widely are actually hurting certain parts of the population because those people are getting upset and pretty much fighting back. So you had, students being sued, students suing Apple for sort of a false arrest. And I think one of the more interesting cases is Uber drivers, multiple cases of Uber drivers suing Uber because the facial recognition system that was supposed to sort of authenticate them as a driver was not able to detect their face or was not able to identify them appropriately. So you could see that there's certain segments of the population that are getting hurt by these technologies. So this is like not great, but it's perfect for sort of the premise of algorithmic auditing, because that's exactly what algorithmic auditing is for. Algorithmic auditing is supposed to be able to take these deployed systems and hold them accountable to identify, the bias and to really, and to make sure that the companies change and are held accountable. And this is something that people have been trying to do for a very long time. So, Joy and I were not the people to invent algorithmic auditing, especially in the kind of human-computer interface community, the HCI community. They've been trying to do a lot of audits of online systems for a very long time, but we noticed that they hadn't necessarily been successful in getting these companies to change, and we were frustrated as to why. So we were able to sort of isolate some of the big challenges with algorithmic auditing. So one issue is that the benchmarks that we're using to evaluate the performance of these models are biased. So the benchmarks themselves don't actually represent the full diverse scope of the people that the models are being deployed against. So because of that, you sort of have this skewed sense of performance, and it's impossible to figure out how the model is performing for that vulnerable group. The other issue was that these audits were not necessarily directly aimed at the target. So if you're trying to figure out if a machine learning model is biased, you want to figure out if it's the machine learning model, if it's the UI, if it's any other part of the system. So they weren't doing a good job isolating the actual model itself. Another issue was the lack of public pressure. So because they were just not naming their targets or naming just one or two targets and not communicating well with the public, nobody knew. And it was just pretty much a researcher pointing at a company by himself. And then the last sort of challenge or issue with algorithmic auditing from the past, and this was an issue that was inherited from investigative journalism where a lot of this originated, was that companies got really mad. They don't like being told that they didn't do something well, and they had a couple hostile corporate reactions and lawsuits and things like that. So people were really scared to confront companies. So the big question that we kind of came in with was like, hey, how can we actually audit these companies and design it in a way that can actually mitigate some of these challenges? So this is the story of Gender Shades, which is, the world's first actionable audit, as we call it, where we systematically designed to address each of these issues in order to get the companies to not just acknowledge that their systems were not performing well, but actually make changes. So yeah, this is the name of the paper, if you feel like reading a paper. So the name of the audit itself, Gender Shades, it was a project that Joy did about a year before. And what is Gender Shades? So Gender Shades is an external, multi-target black box audit. And it effectively audits a bunch of machine learning models in the form of an application program interface or an API. So it's isolated from the rest of the system. And we're auditing for the facial analysis task of binary gender classification. So we're seeing, hey, does this machine learning model predict a woman or a man if it's a picture of a woman or a man? And the interesting thing about Gender Shades is that it took inspiration from different other academic communities in order to address the issues that we were seeing kind of systematically happening with algorithmic auditing. So with the benchmark bias issue, we looked at anti-discrimination law and we took some ideas on intersectionality and representation. For the access to the target issue, we adapted a model, an audit model from the HCI community. In terms of public pressure, we took a lot of inspiration from financial audits. And then in terms of the hostile corporate reactions, we realized that no one really got mad when you pointed out that there was a virus in a particular piece of software, so they must be doing something right. So we took a lot of inspiration from information security, and I'll go into exactly what all of these things are. So the first thing that we addressed was the benchmark bias. And we sort of designed a new benchmark for facial recognition. So, our whole audit system was to audit for facial recognition models for the gender classification task. And we were like, okay, great. Is there any data available that's not biased as a benchmark? And there wasn't, so we created our own. And this is the Pilots Parliaments benchmark. And effectively, it's sort of the first benchmark to be balanced in terms of gender and skin type. So you can see it's like darker skinned and lighter skinned individuals involved in this benchmark. And just to compare it to like everything else, you can sort of see this table is from a paper called Diversity in Faces, where they actually compared the Pilot Parliaments benchmark, PPB, to other popular benchmarks in the community. And you can see that other benchmarks are sort of, much more sort of skewed male and skewed lighter subjects. So it was really the first benchmark that was truly balanced in terms of gender and skin type. And then the other thing that happened was this idea of targeting the actual model and not the developer application. So in the past, when people would try to audit a system, they would say like, oh, let's look at the outcome of the actual application itself. So sort of play the user. And if that outcome is biased, then we know that the system is biased. And we were like, actually, let's look at the actual model itself. Let's like dig in and actually get at the model itself through the API. And that's exactly what we did. So it was just like a little trick to get access to the model, so we could say that the model itself was biased and not the whole system or not the application, and not due to whatever other excuse. And then I guess the other thing that we did was we named multiple targets. So this was like an interesting, very like, it seems like a very obvious trick now, but no one was calling out the companies that they were auditing, so we called everybody out. And then we had more than one audit target so that they could compete against each other. So if IBM didn't do something, then and Face++ did, then they would look really bad, so they would have to do something. And we were sort of counting on that competition and those competitive dynamics in order to get these companies to do something. The other thing too is that we got a lot of press for it, so that was really great because all those companies were exposed at the same time. And then the last thing that we did, and this is sort of the more interesting thing that I think really helped us, was from information security. So I'm not sure if you remember earlier, when you find a virus in a piece of software, no one gets mad that you report it, right? Because it's for the safety of the users of that software. And the company that builds that software needs to know if there's bugs in it. So we used a similar sort of reporting method. So in information security, they have a way to report and communicate about bugs in software that we found was very helpful in terms of communicating about bias in machine learning models. So we called ours the coordinated bias disclosure, where effectively we find the vulnerability, we find the bias or the discrimination, and then we tell the companies first, and we don't tell them who they are. We just, because it's a multi-target audit, so we just show that they're one of these three companies that all performed really badly on this benchmark, and we give them a certain response period to get back to us, and we tell them that we're going to tell, because it's an issue of sort of public concern, we're going to tell the public anyways. The public is going to find out whether they want it to happen or not, but by giving them a response period, we can also release any updates that they have. If they release a new API by that time, we can announce that with the fact that we with the report on the vulnerability. And that's something that happens a lot in information security, and we found that made the relationship with the companies a lot less hostile. At least they couldn't sue us, which is great. So I guess the big question of actionable auditing was, did it work? Were we able to audit these companies and get these companies to actually change? So the companies were like, yeah, we've changed, Kairos says, she actually says, Joy's first studied gender shades, blah, blah, blah. And then, IBM is, we use different training data. They sent us a bunch of great emails, too. And Microsoft, too, was improvement, blah, blah, blah. And then we sort of looked at the actual numbers, and we saw that they did change. So just to clarify what you're looking at, we audited Microsoft, Face++, and IBM, and that was what was audited in the original gender shades in 2017. And then in 2018, we audited these companies again, and then we audited these two other companies, Amazon and Kairos, that were not originally part of the first three. And we wanted to see what the difference would be. So you can see here already that, overall accuracy, the target companies did a lot better between 2017 and 2018. And the non-target companies are sort of the worst performing of the group in 2018, but not by much. It doesn't look that bad. But when you start looking at the gap in performance between males and females, so this is the target companies, August 2018. You can see that males and females are performing pretty on par. The error gap between males and females in terms of gender classification is like 1 to 9% error gap, which is much better because in 2017, the error gap between those two groups was 8 to 21%. Yeah. And then for the non-targets, you're like, whoa, what happened? Like, it's much worse. So for the non-target companies in August 2018, we see that their performance on female faces versus male faces is 14 to 18%, which is a lot. Again, for the targets, so this is looking at skin type, lighter versus darker skin type. So this is us just taking splits of PPB and looking at the accuracy for these subgroups. We see that the difference between the accuracy of the subgroups in 2018 is 1 to 7% compared to 12 to 19% in 2017. And then for the non-targets, it's 8 to 12%. So again, you see the non-targets sort of performing at like pre-audit level for the target groups. And then sort of the big punch for gender shades in that whole audit was taking the different, taking PPB and then splitting it into subgroups of darker female, lighter male, lighter female, darker female, and saying, hey, what's the accuracy of this API for these subgroups? So yeah, you can see Microsoft, it's really funny too, because you're like, oh, like a lot of their improvement was just specifically for this one subgroup of darker females. So you can see a lot of the gap differences that they closed for the other unitary sort of cases were because they made improvements for that darker female subgroup. Also note that the darker female subgroup is still like the worst performing, not by a lot now, but yeah. And then here's the result for Face++. That's a crazy improvement, right? From 65% to 95% for the darker female subgroup. So you can see that a lot of the improvement that we saw in the overall accuracy was really just them improving on this one subgroup. And then here you see for IBM as well, going from 65% accuracy on that darker female subgroup to 83% accuracy, and then sort of staying the same for a lot of the other groups. And then you see the non-targets, who are still sort of really underperforming for this subgroup. I'm not sure if there's any engineers in the room, but like if you deployed a model that performed at 68% accuracy, you would get fired. Like, it's awful. You wouldn't be able to do that. So it just demonstrated sort of the lack of sort of testing due diligence that was going on in terms of analyzing performance across these different subgroups. So, what can we learn from gender shades? What was it good for? There was a lot of things that we thought we would learn that we did learn. So one of them was that audit design matters. And gender shades was so intentionally designed to sort of pit those companies against each other, to name them publicly, to get them to make these improvements, that we expected to see that improvement from 2017 to 2018 for the target groups. And we know that this is something that we can replicate for other audits. So yeah, we were like, oh, cool, awesome. The other thing too that we sort of suspected as well was that ignorance is bliss, but irresponsible. So, in the past, especially after the first gender shades audit, we would get a lot of comments like this, like, it's harder to take a good picture of a person with dark skin than it is for a white person. I didn't put it up there, but because I don't want to shame the guy. He's got a lot of hate on Twitter, but there's another quote from one of the engineers at NIST that wrote this report. And it's something like, Black people look more similar, so... And you're like, okay, cool. He got a lot of hate on Twitter, so I'm not going to bring up his name again. But we were getting a lot of comments like that. So the actionable auditing study was also just a way to like kind of show people that, hey, this is something that people have improved. All the target companies that we re-audited, that was within 7 months that they deployed new APIs. So this is very much a solvable problem. It's not something that's impossible to solve, or at least address. And this is not a good excuse anymore. And then I guess another sort of good lesson from gender shades was if it doesn't work for everyone, it doesn't actually work at all. And this is something that we obviously strongly believe, and we communicate as much as we can. The bias in our benchmarks really skewed our understanding of what performance was for these models, and that really made it clear that people were not addressing the classification bias in their models. So, sometimes there's not actually a accuracy trade-off. If there's people in here that are sort of familiar with fairness literature in any way, or stats, you'll know that people always try to talk about the fairness accuracy trade-off. You're either a fair algorithm or you're an accurate algorithm, and a lot of the time you're not. So here's a case that I love a lot, where if you Google healthy skin, you just see only women can have healthy skin, only lighter skinned women as well. And it's kind of funny because it's like, that's not accurate. Like, I've seen a man with healthy skin before. That exists, right? So this is a case where by making this more diverse, you're not necessarily altering reality in any way or pushing an agenda, quote unquote. You're actually just making it more accurate. And I think that's actually a surprising number of cases, especially with computer vision, where our data sources are so media influenced that we actually have such a skewed understanding of some very simple things. And then, so I guess this is the time where I talk about the other effects of gender shades. And these are things that we did not come out to do. It very much just happened. You'll find out what happened. So one is just the way that companies, governments, and academia reacted. It was very surprising. There were a lot of interesting reactions that we were not expecting. So one of them was just the policy feedback. Here are a bunch of letters, lawsuits, bans, federal bills, state bills, and local laws against facial recognition. And the ones with the asterisks directly reference gender shades or the actionable auditing study as like inspiration or in their memos. So like there was just this huge wave, and I think it was just coincidentally like ACLU was also really pushing, moving against facial recognition at this time, but it was a very important issue to bring out, and the whole idea of classification bias was not something that a lot of people were thinking about. And California's there too, San Francisco's there, so yay San Francisco. And then another thing that happened sort of around the same time was that companies started coming out with these like AI principles and AI design standards, where they said, and I think like one of the first few were like IBM, where we just released a report saying that they were biased, so they were like, oh, we value trust and transparency, we value diversity, and it was really interesting to sort of see these companies really declare their values about AI development so explicitly. And then another sort of interesting outcome was the release of these data sets that actually were more diverse. So IBM released a paper/data set called Diversity in Faces, where they actually collected a diverse set of faces to sort of push forward the development of more diverse facial recognition technology. And then we got some more interesting responses. So this is like Amazon. Amazon was sort of less gracious, I guess. They were the culture was a little bit more stubborn about the results. It was interesting to sort of see that corporate reaction, which was what we were initially expecting. But it was also like equally sort of like humbling and exciting to sort of see the research community like stand up for us and say like, hey, this is research, this is peer-reviewed research that's identified this flaw in your technology, and you need to acknowledge that. So it was really interesting to sort of be in the middle of this sort of wave of support from the academic community that really supported this idea of doing due diligence in terms of evaluating our models to identify classification bias. And then this is sort of like my funniest reaction, like our funniest sort of reaction. So Kairos, shortly after our second study got released, I'm not sure if this is a coincidence, it might not be, but suddenly their cheapest option is $99. So you can't just like, they used to have like a free option, which is what we use to audit their API. So they effectively just put a paywall where I have to pay $99 to audit their model now, so that was an unexpected reaction, but it was sort of smart on their part. You know, if you can't join them, you just make sure that you put up a paywall. So they're not going to end up in our next paper. And then another sort of interesting reaction was sort of a bunch of follow-up audits. So this is just one of a couple audits done by the National Institute of Standards and Technology. So that's NIST. And they have a bunch of sort of official facial recognition audits and benchmarks. So one of them is FVRT, Ferret. If you're familiar with facial recognition, you'll probably be very familiar with these names. And they did a lot of evaluations of commercial systems, and they found the exact same thing we did, which was super interesting, which is that, you know, if you have a model that's performing at, you know, a 1 in 10,000 error rate for like lighter females, it's performing 5 times worse for darker females. So that was their result, which was really cool to see our work replicated. And then ACLU sort of did a similar sort of cheeky thing, yeah, where they took the faces of, I think, Congress, and they effectively put it through Amazon Recognition, trying to see if they were matches for criminals. And they had a bunch of sort of false matches, so a bunch of Congress people, falsely labeled as criminals. Which triggered them a lot. Actually, that was when the first letters sort of came out. And yeah, you can see that this was also their matches. They found that it was sort of disproportionately affecting people of color. Another sort of interesting thing, I'm pretty sure it's not a side effect. It might just have been like good timing. But there were a bunch of interesting follow-up studies looking at just system functionality. So when you deploy these systems in the real world, like, do they actually work? And I think our study kind of showed a lot of issues with the benchmarks that we're currently using, and people began questioning sort of the functionality of some of these systems, which was really great to see. So these are just some recent studies, not necessarily directly related to our work, but in the same kind of vibe of saying like, oh, you know, this is a deployed system, facial recognition system deployed by New York as a trial, you know, in the MTA, and it literally has a 0% accuracy rate. And then same with the UK police sort of facial recognition system, which is like an 81% error rate. 81% of the time they're wrong. Like, it's crazy. So people were finding that these deployed systems were not actually working. Another interesting, and this is like sort of like one of my personal favorites, just because I came from a computer vision background, so it's sort of cool to see people auditing for object recognition and the biases that existed in that space. So object recognition is effectively you take an image and, you know, can I draw a bounding box around a person? And someone, you know, evaluated a bunch of software that was being used in self-driving cars and found that it was less likely to identify people of color, like that were pedestrians walking in the street, which is terrifying. So that was really cool. And then there was a Facebook study recently looking at how you know, there are disparities in terms of object recognition working well for sort of lower income families. So, you know, when I take a picture of a bathroom and I'm trying to identify soap, usually the training data has more images of bathrooms from sort of wealthier families, so it looks very different from a lower income family, and it doesn't work as well. So it's just interesting kind of work that we were kind of cited in, which was cool. And then sort of another intended side effect was the idea of diversifying data. So besides what you guys saw about, you know, skin type and gender, there's a lot of issues with data diversity. So here's just age. You can see a lot of middle-aged, model age is what I like to call them, data samples. But you also have geographic diversity issues, right? So a lot of images are coming from Western countries, almost 80%. So ImageNet and open images are probably used by the vast majority of researchers, and all of these images have that Western bias. What that means effectively is that when, you know, you query for a wedding or you're trying to predict for a wedding, you need to see a white gown. You don't see an Indian wedding. You don't see a Nigerian wedding. You see costume for a Nigerian. So it's interesting how those biases really affect the way our models perform. And then, like, I guess like another sort of funny thing is that it's interesting how the data influences the way that these it results in encoded stereotypes. So effectively, at the bottom row, you have people playing sports. At the top row, you have people playing sports. They just happen to be black. But for some reason, the model trained on ImageNet, which is like one of the most popular image data sets, just thinks they're all playing basketball. Like they're all playing the same sports as the bottom row, but for some reason the model is just like, no, this is basketball. Like rugby, no basketball. Like, no, it's ping pong, no basketball. I was like, okay. So yeah, that's like, that was an interesting sort of paper looking at the stereotypes encoded in these data sets as well. So we know that data is like a huge issue. And like I mentioned, like IBM's sort of diversity in data sets was sort of the reaction in terms of facial recognition and trying to diversify that data. I'm just gonna warn against that though, because I think that's sort of the default solution that people come to. They're like, oh yeah, of course, diversified data, that's like the solution to everything. But then we had like weird cases. So there was the case of a bunch of Chinese companies. This was mostly CloudWalk, which was like a small startup, a Chinese startup, but it also involved Face++, which you'll recognize was one of the audits from one of the audited companies from Gender Shades. And what they did was they effectively bought the faces of the citizens of Zimbabwe and used that to diversify their training set. So yeah, that was awful. That was very sort of exploitive and was a huge violation of the privacy of those citizens, and wasn't really an ethical approach to diversifying their data set. And then the other thing is like IBM's diversity in faces got them in a little bit of trouble because those diverse faces that they were using to set up that data set were actually from random people's Twitter account. Oh, not Twitter, Flickr account. So, you know, I upload a picture of my family and then I'm training my machine learning model and I see my family's face in there. It's, you know, some people found that really alarming and it was a huge violation of privacy and people were having conversations around what is required in terms of consent. But I guess like sort of just to take a different approach or to bring up some other issues, there's this really good quote from an essay called A Critique on Fairness, and it's about the fact that, you know, sometimes we focus on, you know, disparate performance between two different subgroups, and I think people that work a lot in this field feel that, and that's really what Gender Shades was evaluating for, you know, how does it perform on this subgroup versus another subgroup. But the issue with focusing so much on that is that we ignore all of these other issues and other values that are super important to think about. So one of those values or things to think about is, you know, privacy and consent. And this is a huge issue with facial recognition. So one issue is, I guess the way that I like to describe privacy is that if I tell you a secret and you tell everybody else, you violated my privacy. You know, you've told everyone my secret. So if you take my face and you show it to everybody else, if I give you my face and you show it to everybody else, you violated my privacy. And sometimes it's unintentional. So, you know, sometimes it's because of a security flaw in the database was not properly secured. You know, the data was not properly encrypted. But most of the time it's intentional. So, you know, taking a picture for a driver's license, I definitely did not give that picture to ICE. And then there was a case of the Ever app where, you know, people would upload their faces to this photo storage app, and then that app was secretly training facial recognition and deploying it with law enforcement, which is crazy. There's also the idea of informed consent. So this is a really great article. I definitely encourage everyone here to check it out. But effectively, they found there was a sort of investigation by an independent researcher at a group called Megapixels, and what they found was that effectively really popular benchmarks and data sets and facial recognition were sort of sourced through unethical ways. So one of them was brainwashed by Stanford University, and they had set up a camera in a cafe, and they had just sort of extracted the faces from the surveillance of like students, of Stanford students, and nobody knew, and nobody obviously consented to that. And a very similar situation happened in Duke. And I think one of the weirder ones was Microsoft, where Microsoft has this really popular data set called MS Celeb. And effectively, it's just a bunch of web images of celebrities, which seems super fine until you find like your prof is on that list or you find that, oh, my neighbor who has like I don't know, like 500 Twitter followers is on that list. So people that weren't quite celebrities in the sense of being a public figure were on the list and were alarmed by that. So Microsoft actually had to, take some action to communicate that their list was sort of developed in a way that evaluated sort of the public status of different individuals in a way that was appropriate. And then I think probably the most alarming was Clarify, which is where I used to work. I was like, oh, trying to hide my backpack. But yeah, they were caught taking images from OkCupid, just like profile images. So I'm sorry if you were on OkCupid and we used your face to train machine learning models. But yeah, a huge violation of privacy, obviously not informed consent. When you upload your picture to OkCupid, you're not trying to get someone to train a machine learning model on it. And in the case of Microsoft, Duke, and Stanford, they actually delete their databases, which was great, except for the fact that there are at least like 500 shadow versions of each data set. I was working with one from GitHub literally 2 days ago. So yeah, all of this still sort of lives in the web, and they can properly delete it. Another sort of interesting idea in terms of informed consent is the idea of surveillance. So the New York Times wrote another really interesting piece where they took a camera that was set up in Bryant Park, and they literally, because they had access to that footage, were able to track the faces using Amazon Recognition's sort of commercial API to track the faces of the passerby. And they were able to identify quite a few people. Obviously, some people were like, oh yeah, I'm a celebrity. And one of them was just sort of a random optometrist that was strolling by, and you can see the quality of the image that they had of him from the surveillance camera, and they were able to identify him by name. So it was really interesting and sort of a little bit wild how good surveillance is, and definitely something to think about. So again, sort of going off on this theme of what else is there besides fairness, people need to start thinking a lot about transparency. So this was a paper that I wrote a while ago, and it was in collaboration with Google AI's Ethical AI team. And the whole initiative was sort of a plea to the machine learning community to start documenting our models. So we decided to deploy these things called model cards. And what a model card is effectively a way to say, hey, how is my model performing on this subpopulation and on this subpopulation? What is the accuracy rate? Effectively doing a gender shades audit on a deployed machine learning model. So yeah, you can see here, this is a sample model card for one of their products. And effectively what the product was that it was supposed to define the toxicity of a particular comment. And you can see from the model card results that if you mentioned, black gay or black queer, it would automatically give a high toxicity level. So you can see that this is like their version 1, where it says toxicity at 1, and then their version 6 beside it. And you can see the improvement of their model just by looking at their model card. So that was sort of an interesting project. And then there's been sort of other projects. So data sheets for data sets is a really good paper that I like that does a similar approach for data. NLP data statements is sort of for text-based data sets. And then Element AI's sort of data licenses is around a legally valid license, sort of like software, open source software license for your data. So all worth checking out. And then a partnership on AI, because we're sort of like a partnership that encompasses a lot of these other companies that are trying to implement these data documentation strategies. We pulled it all together into this project called About ML. And effectively what About ML is a way to sort of pull these pull the major themes from all these documentation projects together, and then come up with a set of best practices across the industry for how you're supposed to document your model, how you're supposed to evaluate your model in different domains. So this is actually open for public comment. So add your comments if you feel like it's something that you have something to say about. And then I guess another side effect and another thing to think about beyond fairness and beyond sort of equal performance or classification bias is this idea of questioning the ethical use of facial recognition technology, which is FRT. And it's really the question of like, what are we doing with this? Like, what are we actually using it for? And this is like these are just a bunch of the tasks that happen with with deployed facial recognition systems. So like face detection, emotion detection, gender, age, so maybe profiling, ethnicity tracking, and those are the different providers at the top. And then there's sort of the weirder tasks that are not legitimate in any way. So I can't really pronounce these names, but I don't know, I'm not gonna try. But effectively, like, these are a bunch of pseudosciences, you know, from like over 100 years ago, where people sort of decided that you were able to look at a person and decide on their criminality or their hireability. And it's completely bunk science, but there's entire companies, facial recognition companies, built around sort of predicting these things. So criminality, for example, there was a bunch of papers written about, you know, defining criminality based off of a face, or hireability. There's a company called HireView that tries to define how hireable or how great a job candidate someone is based off of their face. Character and personality, you know, sexuality. If there was a Stanford paper looking at, you know, a bunch of faces and trying to see which one was gay. It's just like, you can't do this with the face. So there's a bunch of sort of like discredited tasks that we realized needed to sort of just like not exist. And this had nothing to do with performance on darker females or lighter males. It just had to do with like the invalidity of the task itself. And then another sort of like invalid cases or just things that need to get shut down. One was this idea of, hey, you know, why are we categorizing people based off of gender? Why are we predicting gender in the first place? Why are we predicting race? Is race a valid social construct? What are we doing with that information? Are we targeting those people? So that whole idea of sort of using this technology for the sake of identifying different subgroups became a little problematic, and we realized that was a very not good idea just for the use of facial recognition technology in general. There's also this other sort of thing that happened when you take media data, is that sometimes it just it just automatically gets these labels that are very ridiculous. So for example, based off of the media data that this model was trained off of, which is in ImageNet, again, one of the biggest data sets used in facial recognition and computer vision, if you sort of predict on a woman's face here, you get a foolish woman as the prediction, which is like, okay. This guy apparently looks like a hypocrite. And that was like a label in ImageNet. So it's just very ridiculous situations where, you know, these labels shouldn't exist, these tasks maybe shouldn't exist. And then there's the sort of more sort of like nebulous cases of like, maybe the task is okay, but nobody's actually using it when you deploy it in the real world, and that's the issue, and it has nothing to do with the performance of the model itself. So this was there was a study called Garbage In, Garbage Out, and that was a really great study where it sort of looked at how law enforcement was using facial recognition, and they found that they were doing very ridiculous things, like they were taking sketches and trying to get leads for actual suspects for criminal investigation cases, which was very ridiculous. It's been studied very heavily by NIST, which is the National Institute of Standards and Technology, that has like literally an error rate of 80%, just because it wasn't like the model wasn't trained on sketches. Why would you have as the input a sketch and expect to sort of match that to the right face? So obviously they were having ridiculous ridiculous error rates with that approach. And then Amazon's facial recognition tool. So one of the responses, you know, that Amazon gave after we did our study was, oh, you have to set the threshold to 99%, you have to do this, you have to do this. And like every law enforcement officer that uses our technology knows this, that they have to, you know, set the threshold really high and be really careful in this way when they use it. So then a reporter at Gizmodo was like, cool, I'm gonna investigate this and talk to a bunch of these like law enforcement people using the technology, and they found that none of them even knew what a threshold was. So it was like a really bad look. So the way that the technology is used, even outside of the actual function of the technology itself, is really interesting, and it's a weird place to be. And then the other thing too is like, okay, the technology works really well and the person using it knows how to use it. What if they use it for something that's just really bad? And these are just three interesting, awful cases. So one is the case where, facial recognition was being used with expert precision to sort of identify a Muslim minority group in China and actually target them for concentration camps, which is crazy. And people surfaced a bunch of these old papers that were working to do just that. There's also the case of the Toronto police using facial recognition secretly for more than a year, which was like not very Canadian nice of them to do, and targeting sort of minority populations with that and using it to justify some really problematic decisions. And then there's sort of like a little bit of a weirder case of a Brooklyn landlord that set up facial recognition in front of his apartment in order to monitor his tenants, which is effectively like another form of bullying, right? To just monitor who was coming in and who was coming out at what time. And the tenants actually had to sort of take a stance against him and move into the public and make their cause public. And all of these reasons are sort of pushed Joy at the Algorithmic Justice League to sort of set up this idea of a safe face pledge. So when I create facial recognition, here's some things I'm going to sign that I'm going to, commit to. I'm going to commit to showing value for human life and dignity. I'm going to commit to addressing harmful bias. I'm going to commit to transparency and all of these other sort of positive business practices. And that was her way of sort of showing the fact that hey, beyond accuracy, beyond fairness, there's all of these other issues and we need to talk about them. And we all need to agree that it's not a good idea. And then I guess the very last thing I want to end off with is this idea of paying attention to missing voices, which I think is a lesson that we came in suspecting, but not really understanding the magnitude of that lesson. So there's a lot of people outside of this room right now whose perspective and sort of active participation in machine learning matters a lot. And those are exactly the people that are the most affected or at risk by these models. And it took me so long to fully understand that. It wasn't until we sort of started seeing cases of harm happening, of algorithmic harm happening, that we realized that a lot of the people affected by it are not the people in this room. They're not the people building the technology at all. And there's actually a really great essay blog by Ali, who's this researcher at Stanford. So Stanford decided to sort of spend a lot of money and set up a human-centered AI institute. It was really exciting. There, Henry Kissinger was there, and at the announcement, everyone was very excited. But this sort of anthropology / CS PhD student wrote this interesting piece sort of saying hey, human-centered design is actually about humans. And calling it a human-centered AI institute doesn't really make a lot of sense. That sounds very AI-centered. So human-centered design is really about what the humans need. And sometimes it's very important to ask that question of, do I need AI to solve this problem? Is AI necessary here? And if the answer is no, that is okay if that's the best thing for the humans. So I thought that was a really great piece. I definitely encourage everyone to sort of read that. It really grounds you in what this work is supposed to be about. If it's about helping humans, then we should be inventing excuses to bring AI into the solution. And then the other interesting thing that he said, which was very drop the mic, great work. He said that, we're all sort of sometimes sitting in a room making decisions on behalf of this population that is affected by our decisions. And, we are so sure that we know exactly how to solve their problems. And we are so sure that, we can sort of manipulate them to do what's best for them. And that really is not a good approach. That's not a human-centered approach to solving issues. And with AI, it really becomes incredibly problematic because you deploy this system and it affects so many people, and those people that are most affected are just not part of the consultation process at all. So I'm obviously not the first person to notice that. There's been a lot of interesting developments happening in the AI community as a result of people sort of coming to terms with the fact that the technology that we build and the models that we build really don't affect us as much as it affects others. So there's a really cool workshop at the Computer Vision at a premier sort of CVPR, which is like computer vision and pattern recognition conference. It's one of the premier sort of like computer vision conferences. And they had a huge workshop on sort of computer vision for global challenges, which is sort of like computer vision for like international development. And they brought in people from Thailand, from different African countries, and they had them speak about how they were using computer vision and what they needed help with. And it was super helpful just because it was actually people that were experiencing things, that had experiences to share, and we were just kind of like in a listening position, and we weren't trying to invent answers or come up with stories about how they were living their lives and what they needed. They were just sort of there engaging with the community. So it was a really cool moment for the computer vision community, that conference, that workshop. And then sort of another initiative, and this is something that the Partnership on AI is engaging more with, is this idea of diverse voices, where it's like effectively a methodology to engage with experiential experts, so people that have lived life, lived a valuable life, where they sort of have experiences to share that you would not have access to within your company, and you sort of pay those people, and they come in as experiential consultants, and they share their engagement with the technology, they share their perceptions about the technology, and in exchange, those developing the technology sort of get a broader view on what's important. So that's sort of like another interesting sort of approach to addressing that issue of missing voices. And then obviously there's sort of the idea of like, hey, there's women in machine learning, and that's Latinx in AI. So like there's Latinx people in AI, and there's Black people in AI, and there's all of these different communities, and maybe we should just encourage them to really speak up and vocalize their experiences so that we can build technology that really works for everybody. And then I'm just gonna sort of end off with like another sort of thing too, is just to sort of encourage the next generation, and this is something that like I'm just personally really excited about. So when I was, I think after my first year of college, I guess you guys would say, university, I really got into outreach and kind of going into the community around our school and teaching people about coding. And me and a couple of friends started this thing called Project Include, where we sort of went to low-income neighborhoods in the Greater Toronto area, and we just taught them about coding because we were so excited. And this was something that was super important for me to get involved with, just because I didn't learn how to code until my first year of university, and there was a lot of people within my community, like my cultural community, that wasn't very familiar with coding, so I didn't have a lot of mentorship. So it was really important for us to kind of go into these communities as the mentors and really encourage these kids. And we kind of came in thinking like, we'll do like one workshop, and it really blew up because people were super excited about it. So this is how big we are right now, which is crazy. Yeah, thanks. Yeah, it's insane. So we like really grew, and this is probably the 5th year now, which is insane. Yeah, so we just finished our 5th summer, and you can tell we've sort of like spread all across Toronto, and it's definitely more than just me and my friends now. And then we also have like interesting opportunities to expand in weird places. So Mississauga is like a suburb outside of Toronto, and then we had like a random instructor that was like, oh, can I do this in Ecuador? And we're like, cool, go. So she was an exchange student from a university in Ecuador. Their sort of like main university, and it was really, really crazy the situation they had there, where it was just 20 people registered for computer science programs in the university because nobody sort of was aware of the opportunity, and it really frustrated her. So they spent the whole summer sort of going to different high schools and teaching about computer science, which was really cool. And then, so we kind of came into the whole experience, and I think this happens a lot with outreach in general, is you come in being like, oh, I know all the knowledge, you just receive all the knowledge, that's cool, that's what teaching is. And they really taught us a lot. So this is like one of the kind of quotes of like moments that make it worth it, where one of our students is talking about how he wants to code in order to set up a security system, because security is a huge issue in his neighborhood. We also had a student that kind of came up with a project where he built a website to like share like sort of like different balls. So like a basketball, like if he had a basketball and his neighbor had a football, for example, they were able to like go on this website and like share it with each other across the apartment complex. It's just crazy stuff that like definitely we would have never designed or assigned to them, because of the uniqueness of their experience and what they're going through. Just teaching them a little bit of code, they're able to really solve a lot of problems for themselves. So it was really cool to experience that and see that. And then this is sort of just like a quote from the group in Ecuador, where they were kind of experiencing the same thing of like feeling empowered by just being able to code some solutions for themselves and no longer be this like missing voice. So yeah, I think like that's sort of where we are. We've arrived at the end or the beginning again, where it's effectively the whole point of the presentation was just to say that, hey, this is something that's very real and it's affecting people right now. And it's affecting, people that are coming in as well as people that have sort of already experienced algorithmic harm. And then also the fact that our goal should be to make an impact. And I think it's very important to do theoretical work. It's very important to do sort of like futuristic AI harms work of 500 years into the future, sort of that vision of AI and preparing for that vision. I think that's super important as well. But it's like, I don't think there's nearly enough people at all looking at the harms that are happening today and trying to address those, and really thinking about how their work can be impactful and move beyond just proving something or demonstrating something, and really thinking about strategies to design solutions that have that impact. So yeah, that's it. Thank you.